So I'm excited to be here. I'm Chris Cord. I'm a product manager for our VMware AppDefense offering, which some of you may have heard of either from the press release coming from VMworld US or from this morning when Pat talked about it. So I'm also joined by Nigel Kirsten, who is the Chief Technology Strategist at Puppet. So we're going to actually be going through AppDefense in a little bit of depth, and we're actually going to be talking mostly around the process in which we use to create what we call the virtual machine manifest, or to create this notion of what the intended state of the security profile of a particular application or virtual machine is. So we'll kind of really deep dive on that for the most part, which is kind of one of the unique, I think, aspects of the AppDefense solution, is the idea of creating and understanding this intended state. And then we'll talk a little bit about the other aspects of the product, which is mostly how we leverage the hypervisor to do detection of anomalies and behavior from a security perspective and how we do remediation. But for the most part, those will be lightweight in terms of the how we talk about the other pieces of the solution. Other thing that we'll do is we'll actually be able to see the demo. So Nigel will come up, we'll talk a little bit about Puppet, talk about how we leverage Puppet, and specifically what Puppet can be used for within larger enterprise deployments. But then we'll also go through and actually watch it in action. So we're going to be showing a more detailed demo tomorrow during Tom Korn's spotlight session at 12:30. But today we'll actually be able to go through a demo of the actual running system, and we'll show some examples of attack behavior that we can stop, and we'll also show examples of things like how we integrate into Puppet and how we actually pull information from Puppet in order to populate the manifest, as well as things like dealing with upgrades, operational upgrades. So this is a question that comes up often inside of AppDefense, which is how do you deal when behavior on the machine may change for perfectly legitimate reasons, like when an upgrade happens. So we'll show exactly, how we behave when we do get a software update, on the machine in real time. So one big question is sort of why even try to solve this problem? Like, what are the things in the security landscape that we're actually looking to address, given AppDefense? So I kind of bucket the most data center security use cases or data center security situations kind of in this relatively simplistic picture. But essentially what you have is a very small sliver of things that you can classify as known good behavior when you're dealing explicitly with data center behavior for the most part. And you can classify some things as known bad, right? So you can sit there and say, am I looking for a bad IP address? Am I looking for, a bad hash or some signature that is known bad? And there's a small set of indicators and behavior that you can actually address and see with that. But then you're essentially left with an awful lot of just bucketed gray area. And for the most part, the default answer in the security world for that gray area is dump it into a SIM system, a security event management system, or dump it into your back-end packet capture or analytics system, and then just throw some people at it. So there's a couple of things that people do. They go and look and say, I want to do some rule-based analytics, which is a typical SIM-based approach, where they would say inside of Splunk or inside of ArcSight or QRadar, I'm going to write some rules, some correlation rules, and I'm going to try to catch certain behaviors by looking at correlated events. A good example would say if you reach a certain threshold of invalid firewall requests, if you get past 5 invalid firewall requests, then I'm going to trigger an event and an alert that I should be aware of. So that works in some instances. In some cases, you're able to see some things and correlate some things. But for most attack behavior, those things are difficult to find, number one, and they cause an awful lot of just false positives that you have to deal with. The other thing that people use is essentially just good people, right? So they're going to go out and say, look, I'm going to hire some really good SOC analysts, security operations center analysts, and I'm going to have them sit in front of the screen. I worked at RSA prior to coming to VMware, and we had a product called NetWitness, which was all about full packet capture. We captured a bunch of great forensic data on the network to be able to sift through. At the end of the day, what really was required is an analyst sitting in front of that screen, looking through all the packet information and trying to figure out whether something was bad or whether something was perfectly legitimate. Unfortunately, that just doesn't scale, right? It works for the very high end of the market. It works for people who have extremely, mature security operations practices. But for the vast majority of the market, they're not able to have that level of talent actually making sense of all the information they're getting on a regular basis. And even if they were, they're still likely not going to catch everything just because of the human error that's involved. And then there's sort of a new, more emerging space of doing more machine learning analytics and tactics on top of data, which is a perfectly valid approach, right? But it's a a situation where it's a fairly nascent market. So the idea that you have more mature machine learning capabilities or enough mature machine learning capabilities to just layer on a bunch of log information is, a somewhat early stage approach. So for the most part, there isn't really good methods to deal with that large swath of gray area that you're left with inside of the data center. So our approach with AppDefense is actually what can we do to help kind of really shrink that gray area down as much as we can and hopefully get it down to practically zero, right? And the way we do that is essentially modeling good behavior, trying to get an understanding of good behavior and how essentially every machine or every application should behave inside of your data center. And once we have that model of good behavior, then it becomes very clear when things start to deviate from normal. As things start to pop out of the good behavior range, then very quickly you can classify them as something that is either known bad, right, because the good behavior essentially has already been pre-modeled. And then you might be able to do some things to quiet, if it is good behavior like an upgrade, you can do things to quiet it in the back end. But the amount of times you have to deal with the false positive anomaly is a lot smaller in that case. And we often use this example. I liken this example to sort of a doctor-parent relationship. When I had my first child, the one story I remember is that we were in the hospital for 5 days or so because my wife had a C-section. And every 15 minutes, the nurse would come in and basically wake up the baby, completely, get him all riled up, take his temperature, and then walk out. And I said, wow, this must really be important. They're taking his temperature every 15 minutes. Something must be going on here that I should be replicating at home because they're waking up the child every 15 minutes and it's driving us crazy, right? So, when I saw our pediatrician for the first time, I said, should I be taking his temperature every 15 minutes? Because that seems like what they're doing normally at the hospital, and that seems like it's something that should be done if it's that important. And her answer was, look, you should know everything about your child in terms of understanding whether they're good or whether something is wrong, right? So the first line of defense should always be you telling me or you observing behavior that is potentially anomalous or potentially bad. And after that, we can look and start searching for the maladies or things that I should be concerned about. But prior to that, you really shouldn't be alerted or shouldn't worry about behavior until you start to see those indicators. And that's kind of essentially what we're thinking about here, which is that in a situation where the doctor, essentially knows how to treat and deal with threats, and a parent knows the details about their child and know how to understand when something is good or when something is bad, we sort of need to build that level of relationship between the security users, right, the people who are running security operations centers, the people who are security architects, who are essentially experts at finding threats. Their job is to look and understand for malicious behavior and understand how to classify that malicious behavior and potentially remediate the issues that they're seeing. But they're not necessarily the experts in the environments in which they're asked to protect, right? They're not the ones on a day-to-day basis who have to run infrastructure. They're not the ones on a day-to-day basis who have to run applications, who have to configure those environments, who know it like the back of their hand. That's typically your infrastructure administrators or your application developers that know those environments very well. So there needs to be a better alignment or a better handoff between these two entities in order to actually have a more consistent and better approach to dealing with security incidents. And this is not just something that, is nice on a one-off basis. I mean, this is something that happens on a regular basis every time somebody wants to update infrastructure, every time someone wants to update applications. Essentially, all those things create some level of friction or burden between your security users and your infrastructure administrators. They're either there to slow you down, meaning the security teams are just there to kind of slow down your ability to run and develop at very fast pace, or they're not able to do their job effectively because they're not able to deal with security incidents in an appropriate manner because they don't understand the infrastructure very well. So if we can really align these two cases, if we can start building a better model between these two, we can really, I think, transform the way we do security operations in general today. So in my mind, this is a very, very important, alignment, workflow alignment between these two silos within the organization. And the way we look at that is if we can do this well, if we can build this bridge and do this well between the security users and your infrastructure or application owners, we can kind of shift away from the traditional method of doing security, which is today, essentially digging for threats. It's that model in which you knew nothing about the environment in the first place, and you're just sitting there looking for all the potential bad things that can happen. This is the de facto standard, right, for what you want to do or what you are doing today to secure your environments. And it's, all the problems are there. I mean, we can see with all the incidents that we're dealing with today that this is not the most effective model. So it's highly noisy. It's you're constantly dealing with an array of threats and behavior that's constantly changing. So it's not easy to stay on top of those things. So we can want to shift away from that to actually dealing with a new model that's focused on validating intended state behavior. So validating the good behavior that you expect to see. So if we can build a very well understood model, right, of intended state and understand exactly the way your virtual machines and your applications should behave, it's much easier to then continually validate and watch for that behavior to make sure you are seeing what you expect. And you'll wind up seeing a lot more threats, and you don't necessarily have to deal with understanding or worrying about the new incidents that are popping up or the zero-day threats that are happening. Because any one of those things, any zero-day event is actually going to just create different types of behavior within your application. So you can look at a much smaller subset of entities, validate those things on a regular basis, and actually catch more things in the back end. So if you're able to deliver this model, it actually becomes a much better security model for your data center overall. And this is not just us that say this. This is a great slide from Gartner. This is something which they publish in their cloud workload protection platform or cloud workload protection paper. And it basically looks at all the different things that you should be doing inside of your data center assets, right? And when they say cloud workload protection, they're essentially looking at data center endpoints. That's their method in which they talk about data center endpoints. And essentially what they're saying is when you're looking at data center endpoints, server workloads, they require just a fundamentally different strategy to secure them than what you're going to deal with an end user endpoint. Because data center workloads can be modeled. They're well understood. They have they're in an environment where you should be able to understand their intended state and why they exist. Machines just don't suddenly, database machines don't suddenly start acting like web servers. That just doesn't happen, especially when you're in a situation where you have virtual compute instances that are ephemeral and can be spun up and spun down on a regular basis. So they have a well-defined role in life. And if you have a well-defined role in life and we can sort of model that well-defined role, then it's much easier to start create more intended state security models in those things. Whereas end user machines, your laptops, don't really have a really good, well-defined role in life. They can change on a regular basis. End users can install new software. They can start exhibiting new behavior on a regular basis. And that's the reason why, you tend to have more of a threat hunting type model for end user machines. When you're dealing in your data center, you shouldn't have to do that. So if you look at the bottom end of this pyramid here, if this thing can work, you essentially see network segmentation and firewalling, right above vulnerability management, as a core workload protection strategy. We believe very heavily in this at VMware with VMware NSX, which is our core microsegmentation solution for the network. But then right above that, the three rungs above that are system integrity monitoring, application control and whitelisting, and exploit prevention. And these are all things that VMware AppDefense provides. So these are foundational security elements that we believe round out the microsegmentation story inside your network or inside your data center in order to deliver essentially these core workload protection strategies, right, that Gartner describes. Unfortunately, people just don't deploy these types of things on a regular basis. Most people start on the opposite end of this pyramid. The first thing that they do is deploy AV. So they have AV running for their end user machines, and they say, well, I'm just going to take AV and deploy them on my data center assets as well. And that's the last thing that a firm like Gartner says that you should do. So we believe very heavily in this model. And we think that if we can ease this burden of understanding what the proper intended state is of your data center, then effectively we can deliver on this promise of having a set of core workload protection strategies that are more effective than what you're currently left with today, which is dealing with things like AV that are hunting for malicious threats. The other thing, just talking about AV in general, is that AV has to create a consistent model, one consistent model. There's not separate AV models for data center assets versus endpoints, end user machines. So they have to create one consistent model that works across both of those things. And that's just, again, because the differences in behavior and the differences of things and types of threats that you're looking for between these two models, it's just an almost impossible task to be able to have a consistent model that works across these two different types of machines and do it at a high rate of effectiveness. So that's the other reason that they, essentially say that these are things that are just not that appropriate for your data center workloads. So this is essentially why we looked at creating VMware AppDefense, right? And it's broken really into three major buckets in terms of the product capabilities. The first is the creation phase. This is what we'll be spending most of the time today discussing, which is, when we want to understand and create intended state, and we want to be able to enforce this application control model on the back end. The first thing you'll need to do is really create the appropriate intended state manifests for your machines. And there's a very well-defined process that we put in place for that hopefully relies on as little manual interaction as possible. So we don't want to have a bunch of people creating these rules on a very granular basis to be able to create this intended state model. That would be difficult, annoying, and probably impossible to do. So we go through a process of actually delivering that, which is what we'll talk about today for the most part. The second is the detection phase. So this is after you've gone through the creation aspect and you've more or less modeled your intended state behavior. How do you then start enforcing that? And this is where we actually leverage the hypervisor as a method of enforcing and validating the intended state from the first piece. So, we have situations where we're looking at the operating system kernel directly from the hypervisor to ensure that nothing is manipulating the operating system kernel. Then we start looking at user space behavior, processes, network behavior coming from that endpoint to make sure that it's all matching back against the VM manifest that we see in the beginning. And again, I'll talk more detail about what the manifest is and what it encompasses, just to give you a general sense of exactly what we're looking for. But that's the middle bucket, which is, how are we then managing and controlling behavior once we understand what it is intended to be in the first place. And then the last piece is the response aspect. So this is the aspect of the product that says, what should I do when I see a violation in behavior? So once I see something from the intended state behavior actually not being followed at runtime. So if immediately and during the detection phase, I start to see anomalies in behavior, how do I then respond to that? And what do I do about it? And this is where we actually can take a number of different actions or response routines based off of the anomaly that you see. So the first thing that we could do is just block it. So we can just simply block the behavior directly on the endpoint and say that the behavior just is not allowed to run in the first place. This is an example of if you wanted to implement application control and essentially say that I want to control the environment and make sure that these things can't happen in the first place. That's perfectly doable with AppDefense. Other things, though, could be more nuanced and more orchestrated in terms of the remediation that you want to take. So you can simply alert, and you can say that I just want to alert my users or my security users that some anomalies in behavior are happening. We also announced with IBM QRadar an integration as well as RSA NetWitness an integration, and we'll be rolling it out to other systems like Splunk, where we're simply sending these alerts, these anomalies in behavior, to your SIM system or to your alerting system of choice to say, hey, there is something that you should be concerned about here because it's acting differently than what I expect. More interesting than that, though, is our ability to leverage the virtual infrastructure as a response or remediation mechanism. So this is where we can tap into some of the automation techniques of virtualization to handle a security response that might be multi-layered. So a great example of this is inside of NSX, if you're aware, we have a capability called Service Composer, which allows us to change the security profile of a virtual machine on demand. So I can insert a new third-party service on demand. I can say that I want a Palo Alto Networks firewall inserted between two virtual machine calls because I see anomalies in behavior happening at the application layer. The other thing you can do is say, I'm going to start doing full packet capture. So I can start kicking off a full packet capture event for a particular VM using NSX Service Composer based off of anomalies in behavior that I'm seeing in AppDefense. We can also take action inside of ESX if you want to snapshot machines for forensic analysis later on, or even go to the level of suspending a virtual machine if you start to see heavy violations in behavior. All those things can be triggered and orchestrated as response mechanisms in AppDefense. So when we go through the demo later, we'll actually show this. We'll show a situation where we have someone trying to manipulate our protection schemes inside of AppDefense. And effectively what we'll do is wind up suspending the machine. So we'll first show a case of us blocking behavior and doing an application control use case. And then we'll show someone trying to turn off or manipulate the mechanism that we're using to watch and control behavior. This is essentially, the integrity scheme underlying an AppDefense. The hypervisor will recognize that and it'll actually kick off a suspension action on the machine. So that's one of the unique aspects of this solution, is this notion of completing the loop on the response side of things. So again, the focus here is going to be on that creation phase for the most part, and we do have some sessions later today where we'll talk about AppDefense generally as a whole, and then tomorrow we'll go into much more depth on the spotlight session. So if you are interested in the kind of other aspects of the solution, we'll get deeper in that in the other sessions. But here we'll really focus on this challenge, which is, how do you understand behavior? What's the method in which we use to understand behavior? So this is one thing that when we talk to customers, they get very sort of interested in, which is like, I don't want to have to create these manual rules. How can you help me either do this on a regular basis? How can you do it at scale? And how can you do it on an operational basis over and over and over again to make sure that this is not something that's going to cause an undue burden? And one of the things that we're looking to solve is what I view as this broken process today between your application developers, your infrastructure administrators, and the security users. And we actually just went through this process internally. So, AppDefense is deployed as a VMware managed service. It's something that we run and manage as a SaaS service. So in order for us to actually deploy and run it live, we had to go through security reviews with our internal security operations center, right? Because they're the ones that are going to be responsible for watching it on a regular basis and making sure that the environments are secure. So it sort of went like this, I would say. We built the application. And we knew most, if not all, the behavior around it. We were the experts in the app. And then we were asked to go through a manual security review process, right? Which essentially was a set of reviews, and I'll show some examples of what they asked us to do. But it was more or less a lot of questionnaires. It was a lot of spreadsheets. It was a lot of architecture diagrams and countless number of meetings that we had to go to with the security team. To essentially inform them about all the things that we expected to see around our application, all the ways in which we might change it or touch it in the future, all the things that they need to be aware of so that they can trigger the right response mechanisms back to us. It was a fairly painful process for the most part for us to just roll it out. And then we deployed it. And we essentially now are in a situation where we deploy to production every week, if not faster than that. So the amount of times that we're changing the application on a regular basis, right, given the fact that we're running a modern application developed in the cloud and we can change it on a regular basis, is way too fast for the security team to actually be able to catch up with. Because we cannot go through that process, that multi-month process on a regular basis, and actually inform them of all the changes that we're making. So luckily, most of the changes are not necessarily entirely new behaviors that you have to see, but the reality is at times there could be new behaviors. We could introduce a new feature at any point that might start creating new behaviors on the application side. So this is a broken model. Most organizations work like this today, where they have this manual security review process. And given the nature in which DevOps and infrastructure owners are moving at this point, and the type of speed that they can exhibit even using tools like Puppet to do this, it's just way too fast, right? It's way too difficult for them to be able to update security teams on a regular basis. So we need to be able to fix this, right? And this is just one example of the questionnaire, or these types of things that they need to be able to, or they're asking us to fill out today. I mean, this is something, if you consider the amount of automation that we have in place in our environments, and the idea that the security team, and this is the actual part of the actual questionnaire, just a snippet of it that fit on this screen, that our security teams are asking us to fill these types of things out, seems a little silly, right? Again, this is an architecture diagram. This is similar to what they ask us to do on a regular basis. So again, these are static components. I can build this architecture diagram and I can hand it off to them, but then tomorrow when I change the architecture or introduce a new component, how do they get awareness of that? I didn't have to update this PDF and send it off to them and store it somewhere that they can have access to. It's just not the most efficient model for dealing with this. So what we suggest really is this idea of having a more continuous cycle where we're going out and building new applications, and we're doing that on a regular basis. And we instead want to be able to inform security teams and have them part of that review process during the build and deploy cycle. and essentially tap into a lot of the tools that we're using in order to essentially provide builds, provide deploys, and inside of those tools, those automation tools, embed the information that the security team needs to know directly inside of the build and deploy process. So a good example of that is, things that we're doing with Puppet, which is the idea of if you're managing infrastructure, essentially have those hooks built right in for us to be able to pull information. We're also looking at things that we can do inside of deploy process for Jenkins or for Maven if you're doing builds on applications. And any one of those systems, right, any number of systems, have connectors to be able to inform your security teams of exactly what you're doing. And this is something that, a lot of our early stage conversations have come back very positively, right? Because you are adding a step. You do have to have somebody aware that they have to feed AppDefense some information for the most part. But comparatively to going back to filling out, these spreadsheets and these questionnaires, it's an extremely welcome burden for the most part for a lot of infrastructure owners and developers to say, look, if I can just build it into my scripting process and have this thing taken care of every time I do an automated build and deploy, it's way easier than dealing with this automated or this manual process of feeding information over the security team. So that's essentially the model in which AppDefense delivers, and I'll talk about it in a lot more depth. But prior to doing that, I do want to bring up Nigel. Again, Nigel is the Chief Technology Strategist for Puppet. You may not be aware of Puppet, or you may have some awareness of Puppet, but I think it would be great for Nigel to go through it in a little bit more depth, talk about how people use Puppet, and then we'll come back and give more specific examples.
Cool. Thank you, Chris.
Thanks.
So first, give me a note. How many of you in the room using Puppet now? Cool. How many have no idea what it does? It's okay. You can tell me. Okay. My name's Nigel. I'm Chief Technical Strategist at Puppet. I've been using Puppet for about 10 years now. And this whole story that Chris just told is really near and dear to my heart because I think it's what's been at the center of the whole DevOps movement in many ways. What we're seeing happen in security operations now is the same sort of stuff that's been going on for the past few years about how do we align the incentives of developers and operations people. Because as Chris put it, we're not going to achieve the results we need and work at the speed we actually need while incentives are so misaligned. And we just know that the speed that we can now work at with the cloud, with modern DevOps practices, working with agile software development, we can't have security teams just validating production with a series of checklists, staring at logs. That just model isn't going to work anymore. So I'm just going to do a quick overview of Puppet and how we work. So with Puppet, we sort of have a pretty clear, I think, vision of how automation should work. You need to know what you actually have. You want to control what you have and enforce consistency across it. Because we all work in companies that tend to make money, that tend to have compliance, audit standards, we need to secure it and keep it compatible. But perhaps most importantly, we need to keep it modern and perpetually modern. Because the rate of change of technologies that our application teams are delivering as code is only increasing. And so we need to set up systems that let us keep working quickly, keep pushing out change quickly, because the rate of change is only going to increase. And the way we believe in doing this is using a common language across everything. So if you haven't actually used Puppet, we're very much at the center of what gets called the infrastructure as code movement, where you describe your infrastructure in a text-based format and you start treating it like code. So you can start using the tools and the processes that software engineers, honestly, have for decades have been using. Version control, peer review, release branches, all of these sorts of things you can start to actually apply to your infrastructure. So you use Puppet to model your infrastructure, whether it be on mainframes, whether it be in the cloud, public, private, hybrid, bare metal machines, any of those systems, you can actually, Puppet doesn't really care. You just model the infrastructure how it should actually be, and it also makes your workloads really, really portable. And this is actually a really accessible language. And I think one of the few things I would regret about the term DevOps as it emerged was that I think it instilled a sense of fear in a bunch of operations folks that they had to become developers. And I think really it's about absorbing software engineering principles and applying those to what is pretty simple sort of scripting language, really. We've always done scripting in operations. We've always done programming. We just didn't always think of it that way. And we just didn't always practice sort of good software engineering principles. So what we do is we have a model-driven language. With Puppet, you describe the state something should be in. You're not saying the sequence of actions. You're not saying, install this package, turn this service on. It's declarative. You say, this package should be installed, This service should be in this given state. These ports should be open. These files should exist. And then Puppet works out for different operating systems how to actually get there. Inside Puppet Enterprise, we have code management features to let you sort of hook up to your version control repository and do proper sort of release management. So you can actually go, this is a development branch. I want to test it out here on these machines before I push it out to production. We have automated provisioning around it. We're running constantly. Puppet isn't just a day zero tool. You're not just pushing out your infrastructure and then leaving it alone and waiting until it eventually rots. Drift remediation is going on continuously. And I think this is one of the great pairings of AppDefense and Puppet, is that we're normally running every 30 minutes by default, doing various things, but AppDefense actually is a much more event-based system. It's taking advantage of all of that information in the population and taking advantage of the information stored in Puppet to go, what should the systems actually look like? And in Puppet Enterprise, our commercial product, we put all of this stuff together in a nice GUI so you can get visualization and reporting there. Because I think one of the things we've really realized is that as much as we can speed up operations teams and developers and make them work well together, there's all sorts of people in the business who are stakeholders in the state of the infrastructure. Your security teams need to be able to see the history of machines. So one of the really common things we see people do where they get blown away by Puppet is just being able to go, what state was the infrastructure in 3 months ago when a certain incident happened? What changes actually happened? Were they intended changes? Did someone in the operations team go, this is a change that should happen? Or was there drift remediation going on, where the machines were drifting away from their configuration and it was being changed back? Actually, there was one bit I wanted to hit on here too. With Puppet, you don't have to manage the whole system. And I think this is something that actually is really, really powerful for most of the applications we already have in our environment, our legacy applications, or heritage, as someone I know tends to refer to them. You can choose to just manage a small part of the system. So you may be dealing with some horrible monolithic application that isn't modern. It hasn't been built using microservices. It's not built with cloud provisioning in mind. It's some sort of large monolithic application, but you can always improve it with configuration management. And this is something we're seeing over and over again with DevOps in the enterprise movement, is that these are the applications where you can actually gain most of your efficiencies. These are the bulk of your software that you're running. Most of the software we're running hasn't been built in the last few years. Most of it's older than that. And it turns out that we tend to think of these things as a sunk cost. We go, well, you know, there's a team of 4 or 5 people, they keep that thing running. And we don't actually always look for efficiencies that we can gain there. And often it's a really small amount of work, gets you a huge amount back. We've had customers do things like go, look, we can just check all of our configuration files for this application into version control, manage them with Puppet. And now we're actually seeing the differences across different deployments of these applications, and that's what causes this one outage every few months that we never really worked out what the issue was. You don't have to model absolutely everything about Puppet. We actually tell people not to do that. If you're adopting a tool like Puppet for the first time, pick a small building block that runs across all of your infrastructure. If you're on your Linux, Unix systems, you know, pick time synchronization, DNS, you know, because it's always bloody DNS at some point. Pick one of those things that affects just about every service, get that working really well, build up trust in the organization, get that layer more reliable. Don't just pick a single stack and automate it end to end. So this is the old world that security operations people find themselves in. And I think particularly as we've seen people adopt modern practices in development and operations, they're moving really quickly, far too quickly for the security teams. No one's getting extra budgets. People aren't getting extra headcount. They can't keep doing things manually. You can't just keep responding to incidents. We can't have a world where every time, you know, as Chris said, when they're deploying AppDefense itself, they can't slow it down the development of a SaaS application to fill out those checklists every single time they deploy a new version. It just isn't sustainable. You can't be a world where, you know, you're the team that stares at logs and then fills out reports. No one actually wants to do that. You actually have to change your processes as you're going through digital transformation, as you're adopting cloud, as you're building these new applications. And this is where we see the biggest failings, where people just do lift and shifts to the cloud and take existing applications and move them, and they don't change any of their processes. Some of the most horrific stories I've got with customers are where they're just taking old processes that were built for good reasons, you know, 10 years ago. No one's completely insane in this industry. We don't just do things for the sake of it. But sometimes these processes have rotted and they don't actually make sense anymore. And if we actually rethink them and go, Well, now we actually have automation here. We have a system like Puppet that actually describes the state something should be in. Why don't we have the security team be part of the review process? Let's shift left in the pipeline. Let's not just validate when someone else has done their job, but pull security in, let them validate the design. And if you actually have a high degree of confidence that automation is keeping something in a certain state, it's way more efficient for your security teams to be validating the design, then doing light validation in production, knowing that you may have even turned off all manual access to your servers because you're confident with your levels of automation. We've had this all over the place. In EMEA, we have LV Insurance, so one of our big customers. We're really big in financial services all over the place. And all of the customers that are really successful here are the ones that are rethinking their practices as they're adopting new tooling. So we added a few different capabilities. Those of you who haven't looked at Puppet in a little while, with Puppet Enterprise, we added a few new things in the past few years that have really made a huge difference. The first has been direct change control. So we now have a system where as you make changes to your infrastructure inside version control, those changes get released at a very sort of ordered and controlled fashion. And you get to do things like go, I want to just target my European data center, just the machines with these attributes, just the ones running these particular workloads or these workloads globally. You get to actually sort of slice and dice your infrastructure and go, this is where I want to roll out a change. And I think one of the things that Agile's taught us, that we've absorbed in the DevOps movement, has been make small changes but make them frequently. That's how you de-risk your infrastructure. That's how you make things actually much more sustainable. Small changes that are well understood, roll them out really quickly, rather than doing the 6 month, we're only going to open a maintenance window, we're going to pause the whole business while we make all of our changes for a month, and inevitably something goes wrong, and it's such a big complex change, it ends up being really expensive to actually debug. We're providing real-time feedback now on all of those tasks and jobs in the Enterprise console. So as you roll out a new version of your infrastructure, you start to see issues, you can just pause it. So you can start to really formalize in an automated way best practices and operations. Create your canary nodes, test changes on a small subset before you roll out to all of them. And ultimately, because all of this is in Puppet Enterprise, you've got all of that context around you, around all of the facts and the intelligence and the reporting of your infrastructure. So unlike runbook style systems, we get to actually sort of package and define workloads here. And this is one of the really interesting things, I think, as far as integrations with AppDefense and other projects goes. We know what the dependencies are between your systems. So we can start to do things like go, we know that this base building block is relied upon by these 6 other services. And so if I'm going to make a change here, I know which other services it's actually going to impact. And it turns out giving that sort of visibility across the enterprise gets it out of just the small team of experts' heads and it lets many more people make use of it. If you've come across the VRA integration we've done with VMware, which has been hugely popular, this is the sort of thing that you move to a self-service model. And I think this is the direction we're going to see infrastructure, security and development software all go, which is allow the experts to define best practices and then build self-service interfaces for other teams to be able to go as quickly as they need to be able to go. But your DBAs, who are the experts in how databases should be configured, they should get to define that across all of your infrastructure and everyone else just makes use of it. So we have a term, we also have the orchestrator inside Puppet. I think orchestrator may be turning into one of the more widely used terms in the industry. We get to segment your infrastructure based on facts. And that was the stuff I was talking about earlier, being able to slice and dice and go, these particular targeted machines. This is the sort of information that we feed into systems like AppDefense so that we can say, this is what normal looks like. And I think this is increasingly going to be an area where machine learning becomes more and more important because infrastructure is just getting too complex for everyone to hold that state in their head. And we need computers to keep helping us manage computers. Let me just check with the next one. You're jumping on the next slide. So you can slice and dice your infrastructure. You can say, here's a new change I want to make. You can test those changes really easily because you can say, I can de-risk that by just picking, these are my 10 test nodes, or I'm going to pull this machine out of the load balancer, push out a change, put it back into the load balancer. You can start defining these tasks and jobs as entities that any of your, First level, second level support people can start testing in test deployments and then push out to the rest of your infrastructure once they've actually been validated. And because all of this is API driven, you can start putting it into your CI system. You can start having Jenkins fire off. I want to push out a change, I want to test it. If it all succeeded, then release it to the rest of the infrastructure. And I think with that, back to Chris.
Thanks. So one important thing is that Puppet is one example of a system that we use, and I think the interesting thing about it is that it's got a lot of rich information that can be leveraged, right? So when you're actually running and managing an environment with Puppet, all of the things that Nigel just described essentially provide us with a lot of this rich information. So we actually use this in this process we're calling app sequencing, just as a term that we're playing with. But the idea is that we're matching the provision time state or the intended state with the runtime state of the application. And if you have nothing else, if you've started with 0 and you have no ability to have any information coming from Puppet or any other system, essentially we would default entirely to the right-hand side, runtime state. We would just watch things happening at runtime. And in the US, in the same session, we had one of our beta customers who actually just ran through the entire system in runtime state. So it was a good counterpoint to what you can get from a day 0 provision time state perspective. But so there is that match, that constant match between the two that's part of this process. And just digging a little bit deeper into the process, the first thing that we do is actually hook into vCenter and we just pull your inventory, right? So if you have a viewpoint of, your inventory, essentially we can say at that point how much of your inventory is covered from a security perspective and how much is modeled from an intended state perspective. And then we start pulling in the infrastructure configuration systems. We start pulling in the things that we can get from a tool like Puppet to see how much data we can overlay on top of your VM inventory as it exists. On top of that, we start to then look at what we can get from application automation frameworks. So we'll start looking at what something like Jenkins can feed us, or what something like Maven can feed us about the deployments that are happening on top of those systems. So, Puppet might get us a certain level of data, and then we want to pull in and augment from other sources what you're putting on top of those systems. For example, you might know that you're running a Tomcat server or a Python server with Puppet, and then your Jenkins system might actually tell you or tell AppDefense explicitly what's being deployed there and what we expect to see there from an additional layer of detail. And then the last piece is we go through our own process of applying kind of two things. The first is what we call application templates. And we use this in conjunction with some things that we get. So Puppet might say, hey, I expect to see Python as a package on that machine. We know on the back end that Python corresponds to this specific hash or these sets of hashes given the version of Python that we've seen in the past. And then we also know based on some machine learning techniques that here are the sets of behaviors that are indicative of that particular process, down to the port level that we should expect to see in terms of usage from those processes. So that essentially starts getting merged together to create this kind of blended view of an application manifest. And from a detail perspective, the manifest effectively gets pushed down to each VM. You can skip over this in terms of time, and kind of gets rolled out in a viewpoint like this, which is essentially a set of processes on the machine and the sets of behaviors that we expect those processes to exhibit. So if you double click on any one of those behaviors, and we'll show that in the demo, you'll get a blowout of the specific IP addresses, the protocols, the ports that are being used by that particular process, and whether we see that behavior as being abnormal or whether that behavior can be what we call pre-verified. And if we drop it into the pre-verified bucket, that means that essentially it's passed appropriate checks. It's either been fed to us explicitly by someone in the provisioning system, like Puppet, or it's been passed through a threat and reputation feed that we have within our product that's actually provided by Carbon Black. And again, that's an embedded part of the product. It's not something you'd have to have separately or have Carbon Black providing for you. That's something that we just leverage from Carbon Black as part of the embedded pieces of the product. And we run these things all through the feeds, and then we look at what we know about expected behavior or templated behavior. And essentially that becomes something that where we either pre-verify it on your behalf or we expect it to be verified on the back end. And after this process takes place, once you've gone through the full verification process, essentially you come in and now can move this into protected mode, which just says this is all the behavior that I expect to be watching and validating against, and I can now start using the hypervisor to enforce that. So it's this essential process of building this manifest where we pull from a variety of sources that more or less takes away a lot of the burden for creating this intended state security model. So I think from there we go into the detection phase, which again I'm not going to get into in a lot of depth here, and then we go into the remediation phase when we start to see things that are deviating. But absent of just showing you in slides, I think it might be useful for us to come in and just show a demo of it actually working in the last 10 to 15 minutes. And then we can, if there is some time, open it up for conversation or questions. So Treat is one of our engineers is going to come on stage here and just kind of kick off the demo. While she's getting set up, just to give you orientation, what we have in the demo is essentially a 3-tier app. And it's a backend SQL Server database, and then there's an application tier that is essentially load balanced, running Python Django servers for the application server tier. And then we have Nginx as the web front end for this. So this is a system that is managed by, it's set up in an appropriate microsegmented environment. It's also managed by Puppet from an application perspective. Tomorrow in the main session, we'll show actually a full live attack where we're able to use a command injection inside of this application to actually break in using legitimate channels. We didn't really have time for that today, so we're not going to go to that level of depth, but what we are going to do is show you some examples of behavior that could be exhibited on the machine that we can control, such as someone trying to kick off a PowerShell script to communicate to the database, for example, and being able to stop that. Okay. So the first thing I think we're going to look at is just how this environment is described in Puppet Orchestrator. So we are going to be pulling information from Puppet and for us to feed in data to our system. So when you look at the main application manifest, what's happening? You want to just start a new command window?
Yeah, I can try that. Let me see if it's working elsewhere. Yeah, command window.
Okay, we're just restarting the command line window. Yeah, it's this is one of the dangers of the live demo. But
I watched it work like 20 minutes ago.
you know what happens when the network connect, like when the machine goes to sleep, the network connection goes down, and then the command line windows are killed. So. Okay, so what we're going to do is actually going to just run into the Puppet manifest files directly to show the composition of the app within Puppet. The important part about this is going to show us the detail that AppDefense is going to pull in. So when we connect AppDefense into these systems, it's going to crawl through the Puppet manifest and actually start pulling this information in to essentially start creating this viewpoint of the app. Okay, so this is essentially the orchestrator on the application itself. You can see that there's 3 tiers of the app. There's our database tier, there's our app server tier, and there's our web tier. The interesting thing about this is that when we go deeper into one of these tiers, we'll actually be able to see specifically what it's made up of. But at the top, just describing the actual port and protocol usage between the components, right? So this not only telling us that we have these tiers that are described, but that we expect to see communication on these particular ports, which is something that's built into Orchestrator. So we know essentially when we pull this information in to AppDefense that these are particular ports that have been well described and well intended by the application owners. And then if you hop into the app service tier, so this is one of the specific components inside of the app itself. You can see that we're using a version of Python that will be installed and managed by Puppet, right? So Puppet's responsibility will be to kind of push this package and manage this package on a regular basis. So again, this is all information that we can start pulling in and leveraging inside of the AppDefense console. So the first thing that we're going to do in AppDefense is just go in and hook in the Puppet manifest or the Puppet integration, right? So we have this 10-day learning app, which I'll get to in a second, which is after we've gone through the learning period. But first thing we do is we hook in the Puppet integration. And then when we refresh that, we'll see that we actually get now a new scope, which is essentially our day zero scope. And a scope in AppDefense terms is essentially a grouping, an application viewpoint. This is essentially where we look at, here are all the VMs and all the components that make up your application. So what we have is now we've been able to describe the 3 tiers of the app, right? So we understand that there's an app server, there's a database server, and there's a web server. Again, this came from the Puppet manifest data that we were able to see. Specifically in the app tier, we're able to see the members that make up that tier. So Puppet also is managing specifically what components are driving these particular applications. So we're now looking at specifically these VMs are the ones that are serving this specific tier at runtime. And then we can see the composition of the app, which is in this case, given the fact that we know essentially it's a 3-tier app, given what Puppet Orchestrator has described, we understand that this is the app tier, and given those port usage that we saw before in the Orchestrator manifest example, we know that we expect to see communication across these paths between the components of the app. And then going into the packages, we can actually see specifically what are the hash versions of the components that we expect to see on the machine. And again, this is the connection of specifically what Puppet has told us about the environment and then what we expect to see from a hash on the back end. So once that information is there, we actually then go through our learning period. So we round out what we get from a day zero point of view through the rest of the process that I described before to actually round out the system to make sure that we're catching everything that we expect to see. So what we have here is essentially the same scope that's through a 10-day period of learning, right? So this is where you start to see other noise, things that are happening on the machine that are not really indicative of intended state application behavior per se, but rather things that Microsoft might be throwing in from an operating system point of view, or you might have security agents that are installed in the machine. Any one of these things are creating some level of activity that needs to be managed and controlled. And the process that we go through here, like I described before, is not just kind of collecting that information, but whenever we collect that information, we run it through a period of, or a series of checks where we say, look, is this something that we should allow or should verify on your behalf based on a few things? The first thing is, has it been explicitly told to us? So in the case here, we have Python, which is explicitly told to us that it should be there. So we say it's all good. Or if it hasn't been explicitly told to us, if it's another component, we actually go and check Carbon Black's reputation feed to say, is this a known good process, or this is something I should be aware of or concerned about? And if it meets those series of checks, right, if it passes their risk score and their threat threshold check, then we essentially say, okay, we can now pre-verify it. This is behavior that we should be okay with. And again, we're also doing analysis on our own on the back end to see if it matches any particular templates or well understood behavior that we've gotten from the past. So if you click into the Python process, what we also see here is that now at runtime, we've actually observed this process from the application server tier communicating over to the database. So this is something where not only have we seen, we expected to see it based on the manifest data, but we actually have seen this behavior described at runtime, and we know that it's okay because it was explicitly verified by Puppet as something that should be there and should be expected from the very beginning. So this is essentially the process in which we go through to create the full manifest, the full view. There's one situation here where there's a process that needs review. Again, we don't have time to show this here, but we do have a collaboration workflow in the product where we actually send off these processes that need review or the behavior that needs review to your application owners via a mobile app. And we'll show that tomorrow in the main demo because we have a little bit more time. So what you would do in this case is you would send, you would say, I want to verify this as application behavior. It would send it over to our mobile companion application to the application owners, and they'd be able to comment and say, yes, this is good, this is all expected, and then you're able to verify it on the back end. So it essentially gives the security team an ability to kind of kick back exceptions that might be happening that they're concerned about in a more collaborative way. In this case, we're just going to verify this behavior because, imagine that we went through that workflow already through the mobile application. So once we've done that, it moves obviously down into the pre-verified bucket. So now we're in a situation where we have a full set of verified behaviors. So why don't we go in and move it to protected mode. So this is where we understand everything about the environment, we've modeled it appropriately, and now we're actually going to protect the environment. And we're just go in and edit the roles, and I'll explain them later just so we have time. So I'll explain this more, but it does take a minute or two to actually live update the rules. We're just going to set the appropriate settings, and then we're going to commit it. So what we have here from a rule set perspective is essentially a series of 4 different checks, right? So the first thing that we can look at is outbound connection behavior. And this is where we look at every single process in the machine and how it's communicating outbound, essentially how it's touching the network, and using more or less all of the network behavior that you would imagine. It's typical 5-tuple kind of network behavior. And then we verify that that actually matches exactly what the intended state is. Same on the inbound side. If a process is listening on the inbound, we'll verify that that's appropriate behavior. And then we also have 2 checks that are more integrity-based checks, which is we're ensuring that no one's manipulating the operating system. And this is actually directly using the hypervisor to match or to watch over the operating system kernel code. So that if anyone changes anything in the operating system kernel at all at runtime, we'll get immediate notification of that. And it's not a polling mechanism. We're not asking every once in a while. That's an immediate notification that someone has tampered with the operating system kernel. And the same is true with anything to place in the guest from an AppDefense module perspective. So we also watch over and manage the integrity of the components that we have sitting inside the guest. So the hypervisor creates a protected place in memory in the guest where we actually place our components. And we have a component in the guest in order to be able to control behavior. So we want to be able to block behavior inside of the guest, which we'll show in a second. So we have that component sitting there. But the important thing is if someone tries to manipulate it, which we'll show also, then we'll get immediate notification of that and we can take action. So we have this protected kind of anti-tampering mechanism that's sitting there, tamper-evident mechanism that's sitting there. All right, so I think the rules are committed. So what we're going to do is actually just going to remote into one of the machines. So this is the application server. You have to reset that, or you're good. All right, good. All right, so this is the application server. So what we're going to do is just kick off a PowerShell script. And the PowerShell script is just going to try to communicate to the database. So it's using a known good channel, in that channel port 1433, which we have in the firewall rules as allowed, because it has to be in order for the application server to talk to the database. So it's going to try to use that channel. And you can see when it is trying to use it, what it's going to do is eventually time out. And this is AppDefense more or less saying, look, I'm seeing this behavior being used or manipulated by a process that is part of the application manifest, right? So it's putting an extra layer of protection on top of what you would have to have there from a firewall perspective. So typically what you see in a lot of firewall environments is all these things communicating in and out starts to create the firewall looking like Swiss cheese. So as much as you try to segment the environment, it does create some holes. So being able to layer in the application behavior on the firewall is a significant benefit from an attack perspective. So just going back to the console, you'll see that we also report these errors, right, as something that has been violated. So this is a normal feed that would come into the AppDefense console or to your SIM system. And then we tell you explicitly what caused the behavior, the fact that it was PowerShell. It's using a known good port. It's a different processing command line. So then going back to the machine, what we'll show really fast, just because we're running out of time, is actually, before we suspend it, could we just do the upgrade case? So what we're going to show now is just an example of a process upgrade. So we're going to upgrade the version of Python to a newer version of Python. And then we're actually going to then show you how we can recognize that behavior, and it won't be viewed as an alert anymore. It'll be viewed as a provisioning event. And again, the way we do that is actually by mapping in the carbon black reputation feeds. We're going to see that it's exactly the same software publisher. It's a known good upgrade path. Therefore, we're able to pre-verify that behavior. So we're going to limit that or silence that false positive and actually show it as a provisioning event. So what we did is we just stopped the service. We're then going to upgrade to the new Python. And restart the service. Then we probably just need to hit the site. All right, so then we just upgraded the versions. We just, now we're going to hit the website. This is just the front end of the website. Again, we'll show all this in more detail tomorrow, this is an actual running live website. So we're just generating some behavior so that AppDefense is now recognized as coming from a new process happening on the machine. So then coming back in here, it does take a minute or two usually for the behavior to make its way up to the manager from the data plane. So what you see here is at the very top, this is a different class of behavior, right? So in this case, it's now being marked as a provisioning event. And the provisioning event is being recognized because this is not a security alert. This is something that the security team probably should be aware of, but not necessarily be concerned about, because this is something that is a normal operational provisioning event, because we validated the path from known good to known bad. So we don't really have time to show the tamper case. I guess maybe we can show it quickly. Unfortunately, we'll have to do questions after the session. But what we're going to show really fast at the end here is we're just going to tamper the environment. So we're just going to try to manipulate the memory running the AppDefense module and the guest. So when we do that, it's just basically manipulating the memory of that module. And again, AppDefense recognizes this immediately. So what you see here is that it's not necessarily tamper-proof, but it's tamper-evident. So we'll get immediate notification this tampering is happening. And now we've taken the step of actually suspending the machine. So if you remember back to the rules that we set up earlier, we had a suspend rule, and we had that suspend set up as automatic. You can set rules up as manual, meaning that you only take the action after you say, OK, this is an action I want to take. But in this case, we went through an automatic suspension of the machine because that's the way the policy was configured. And then again, you see the events in the back end of exactly why we took that action. Thank you, Mr. Treat. I think that's probably the last thing. So I appreciate everyone being here. Sorry we ran a little bit late on time. But essentially, you can get the sense that we are looking at ways of closing this gap, right, between the security teams and the application owners. And if we can do this well, we can actually create a very, very secure model for your data center assets. So I appreciate everyone being here. Thanks to Nigel. Thanks to Treat.